And a text button with some text. Greetings, Internet scholars. This is your Jesse Stiles. Welcome back to Twisted Signals. Today we are going to get oriented in this coding environment that we will be using this semester, Max, also known as Max MSP Jitter. Let's do this. Max is a graphical programming environment that is made up of things called objects, where every object is like a computer program that takes some input and modifies it and then gives you some output. Data in Max flows from the top to the bottom. So objects have inlets on the top and they process them in some way, and then you get your outlets on the bottom of those objects. Signal processing is usually diagrammed out like this, where you have some input in a signal processing system and an output. So in the world of Max, this would be the paradigm. There are three basic types of Max objects. Max historically has been called Max MSP Jitter, and that refers to these three classes of objects: Max, MSP, and Jitter. And those three classes, they are named in the order in which they appeared to the public. The first type of object being a Max object. So in the original first version of Max, this was all we had. A Max object is going to look like this, and it can take these atomic types of data: ints, which is short for integers or sort of whole numbers; floats, also known as floating point numbers, so that's going to be a number with a decimal place and then maybe some fractional value; symbols, which are strings of text; lists, which a list is going to be a collection of different types of messages. So a list could include combinations of things like floats and symbols. And then a special type of message called a bang. A bang is going to just trigger output without changing any values. A Max object is going to function at what we call control rate. So this is how fast a Max object gives you output, and exactly what control rate is depends on how fast your computer is, but you might expect performance at around 1,000 messages per second. Max objects also will only give you output after they receive some kind of input message in their left inlet. So on looking at these inlets up here, we have a input message in the left inlet will trigger the output. So this leftmost inlet, it's also sometimes called the hot inlet because it triggers output. You can send messages to the right inlet, and these will change values to whatever the object is doing, but it does not trigger output. So that's something to remember that comes up all the time. You need to remember that one of these inlets is hot and the other one is not necessarily going to trigger output. And then you've got the output, the result of what happens when these values are passed into this object. MSP objects appeared in this coding environment once computers got fast enough to work with real-time audio. So the difference between a Max object and an MSP object is that an MSP object can take a new type of signal as input and provide a new type of output, which is audio. Audio signals function at audio rate, and audio rate is way faster than control rate. Audio rate is going to typically be 44,100 messages per second or faster. So that's like 44 times faster than control rate. So these are going to be more intensive in terms of what your computer has to do in order to do audio rate processing. Another critical difference between these types of objects and max objects is that these are only going to work once you explicitly turn audio processing on in max. And there's a couple different ways to do that we will look at, but you can go to your options menu and then look at your audio status to make sure that it is turned on. Another kind of big difference in terms of how these operate is that once audio is turned on, these objects are always providing output. So there is no hot inlet on an MSP object. It's just constantly dumping out audio rate data. So looking at the inlets on this type of object, it can accept all the things we already talked about: integers, floating point numbers, symbols, lists, and bangs. And in addition to that, you can send it an audio signal. It might have other inlets that could also accept audio signals or any of those other types of messages. And then we're going to have outlets on the bottom, which are going to be providing audio output. MSP objects can be easily differentiated from other types of objects two different ways. One is that all MSP objects end with this symbol, the squiggle, which is also known as a tilde. So when you see an object that ends with a tilde, you know it's an MSP object. You know it is going to accept and output audio rate signals, and you know that it only works when audio processing is explicitly turned on. You can also visually tell that audio signals are going in and out of these objects because audio signals in Macs have these yellow stripy cables. So when you see yellow stripy patch cords going in and out of objects, you know that it's going into an MSP object. The third class of objects that we will be working with are jitter objects. These were introduced in the early 2000s when personal computers got yet more powerful and could begin to do meaningful work on real-time video signals. So the special type of data that you can send and receive from jitter objects are matrices. So a matrix is a large multi-dimensional array of data. When we're working with video signals, that means it's an array of color values. So you're going to have an X, Y matrix of data, and inside of that matrix you have all this red, green, blue color information, which when you sum it all up together looks like a picture. And when you provide lots of pictures one after the other, you have video. So these messages that refer to matrices are going to look like this. They will say things like JIT underscore matrix and then some randomly generated name. And this refers to a chunk of memory inside your computer, inside of which this large array is stored. So lots of different objects can refer to that matrix and do transformations upon it. In addition to working with matrices, jitter objects can work with all the other basic types of things that max objects work with. So that would include ints, floats, symbols, lists, and bangs. Jitter objects are in some ways similar to max objects insofar as they are going to function at control rate. And when we're producing video, this is what determines the frame rate of the patch. So whatever frame rate you're able to achieve is going to depend on how complicated your patch is and how fast your computer is. Also, similar to max objects, jitter objects are only going to provide output after some input is sent to the leftmost inlet. So like a max object, a jitter object has a hot inlet that will trigger the output, and it'll have other inlets potentially, which could change some functionality of how this object works, but it's not necessarily going to trigger output when you send a message to those right inlets. So that's a critical thing to remember when we're thinking about orders of operations. We should think about what is going to actually trigger output from a jitter object. One last thing I want to say about jitter objects is just how you can tell that you are working with a jitter object. You can differentiate a jitter object from max and MSP objects because they all start with this prefix JIT dot and then the rest of the name of that object. So jit.matrix, jit.world. These are all examples of jitter objects. You can also tell that a signal that's going in and out of jitter objects is a special matrix or texture signal because it has green stripy patch cords. So when you see those green stripy cables going in and out of objects in a max patch, you know that that is a jitter message. There are different ways that objects are represented in max. Many of them just look like these blocks that have names and then some parameters specified just as text inside of the canvas on which you're creating your patch. But some of the objects in max are graphical objects. So graphical objects work just like all the other objects we described, but they have some kind of user interface. So you can click on them and they might display their data in a graphical manner. Something that's important to remember about graphical objects is when we go to click on them, you can only do this when the patch is locked. So your max patch is either locked or not locked. When it's not locked, you can edit it, you can select things, you can move them around, you can delete them. But when you click on them, you're not going to be using the user interface aspect of these graphical objects. You need to lock the patch in order to interact with them that way. Some other things to keep in mind about objects in max. Some objects have many different outlets. In those objects where there are multiple outlets, you're going to get output in a very specific order, which is right to left. So the first output is going to be the rightmost outlet, and then the next will be the one to the left of that, and then left and left, and so forth. And the last output you're going to get is going to be the leftmost outlet. So you can say in max, data flows from the top down and from the right to the left. These are just some short codes that you're going to see when you're working with max. So integers are going to be referred to with an I, floating point numbers with an F, symbols with an S, lists with an L, and the special bang message with a B. Again, a bang is going to trigger output from objects without changing any parameter values. And some of the keyboard shortcuts that you're going to be using day to day when you're making max patches are these. You can type N in an unlocked max patch, and that's going to give you a new max object. You can type I, and that's going to give you a graphical integer. You can type F, and you'll get a graphical float. B will give you a bang button. T will give you a toggle box, and C will give you a comment box, which is really good when you're trying to leave notes for yourself about how your max patch works. All right, so let's make a new project in Max that demonstrates some of these concepts. Programs made in Max are called patchers or patches. So we're going to go to the File menu and make a new patcher, and we get this big empty canvas with some toolbars on all sides of it. On the lower left, we have the lock button, which locks and unlocks the patch. When it's unlocked, we can edit the patch. So we can add objects to the patch, connect them together, change their states, and so forth. So let's make a new object in this patch by typing the letter N, and that gives us a new object. Let's make a random number generator. One of the hardest parts of learning any new computer programming language is just learning the names of all the different functions that you need to use inside that program. And so when we're learning Max, we're not necessarily going to remember the name of every single object that we want to use, or maybe we're using it for the first time, so how would we know the name of this? And there are hundreds of these objects. So one of the things that makes learning Max easy is the autocompleter. So we could just start typing the word random inside this object, and the autocompleter shows us every object that's available that has the word random in the name of it or in the description. And this first one is actually the one we want, random. It generates a random number, but here are other objects that do random things. So some different flavors of random number generators. So we can auto-complete this to say the word random. And then let's type a space. When we type a space, the autocompleter shows us two other things about this specific object. This is arguments and attributes. So both of these are parameters for the object that changes how it operates. Arguments are going to be parameters that are specified in a specific order, and we can specify as many of them as we want as long as we stay in that order. So this has two possible arguments. The first is the range, and the second is a seed. So let's just specify that first argument, which is the range. We'll say 100, and this is going to be a random number generator that outputs values between 0 and 1 less than that argument. So this will go up to 99. And including 0, that's 100 different possible values. Let's look at the output of these using an integer number box. So we're going to type the letter I, and that will give us an integer number box. If we want to see what the outlets and the inlets do on Max objects, we can hover the mouse over the outlets and inlets, and we'll get a clue window that pops up and shows us what these output and input messages are. So here we see the clue window popping up and showing us that this is the random number output. And let's connect it to the inlet here, which is going to set the displayed number or repeat it to the output. And now let's trigger some random numbers. So the left inlet, this is the hot inlet, which is going to cause the random number output. So we can do that using a bang button. B is the code that gives us a bang button. And let's connect that to the inlet here. And we would want to click on this button to cause the number to output. So we click here and it doesn't do anything because this is an example of a graphical object. The only way to actually interact with it is to lock the patch. So let's lock the patch and then click on it. And you can see we're getting random numbers within this range of 0 to 1 less than the argument. Cool. All right, so let's turn these random numbers into sounds. Let's use these random numbers to set the frequency of an oscillator. So we're going to make a new object. This is going to be our first MSP object, which is going to synthesize audio. And let's say we want an oscillator, maybe a sine wave oscillator. That's going to be the most simple oscillator we can use. But we don't necessarily know the name of what that object is yet. You could just try typing the word oscillator, and the autocompleter shows us every object we can use that has that word oscillator in its name or in its description. And right here we see the sinusoidal oscillator. So the name of this object is cycle, tilde. We type a space, and we can see that cycle tilde has 3 possible arguments, as well as 5 possible attributes. Let's set the initial frequency for this by specifying this first argument, which is the frequency. The frequency is how often this oscillator is going to repeat itself. So if we say 110, that's going to be 110 repetitions per second. Now let's play this sound in our speakers. And to do that, we're going to add an object called DAC tilde. This is the audio output. And DAC stands for the digital to analog converter. It's going to take this digital representation of an audio signal in our computer and convert it into an actual analog sound that we can hear. So let's connect the outlet of cycle tilde. This is the signal output to the left inlet of DAC tilde. That's going to be the left speaker. And the right speaker. And I immediately heard sound when I did that. This is because I had already turned audio on in Max. You have to remember these MSP objects, they only are going to work when audio is explicitly turned on. So when you open the program for the first time, audio is not on, and you're not going to hear anything if this is your patch. There are a couple different ways to turn audio on and off. One is you can go to the options menu and you can look at your audio status. And this actually lets you look at a bunch of things. You can change your input and output devices if you have different sound cards that you're trying to use. And you can turn audio on and off with this power button. You can also do it right down here in the lower right part of your patcher with this power button here that says audio on and off. And right above that is a very handy feature. This is like the main volume fader for your Max patch. So if you don't know how loud something is going to be initially, you can always start off by just pulling down the volume and then turning audio on and bringing the volume up until you hear something at a comfortable volume. Okay, so audio is on. We can hear this sine wave. It's repeating itself 110 times per second. Let's try to change the frequency of it by using the output of this number box to set the frequency of cycle tilde. We could lock the patch and then just click this number box to set different frequencies. And now we could use our random number generator to randomly generate frequencies. Now you'll notice that some of these frequencies are almost too low to hear. So the range of human hearing in terms of frequencies is like 20 cycles per second is the lowest thing you can perceive as sound. And that's so low, it's like sub-bass. It's almost like a rhythm. And then the highest frequency that we can perceive as sound is going to be way high up at like 20,000 cycles per second. So this is an important thing when we're working in Max, is like we need to always remember what are the units that we're using and what is the range of those units if we want them to do something useful. So this range of 0 to 99 is actually not super useful if what we're trying to specify is the frequency of this oscillator, because the range of human hearing is like this way bigger range. So why don't we start off by just offsetting these values? We're going to add something to them. And we're going to make a new object to do this, which is just plus. It's the addition object. We'll type a space, and then we can set some initial value as this argument. So let's add 110. And then let's take this patch chord and delete it, hitting the delete key. We'll take the output of this number box, go to the inlet of addition. Let's actually make another number box to look at the result. And then we'll use that to set the frequency. Let's lock the patch, turn audio on. Okay, so there's some random frequencies that are more audible. And we could increase the range of this by just changing the argument to our random number generator. And that's a broader range of random frequencies. So at this point, my finger is starting to get tired from clicking this button over and over again. So let's make an object that will automatically generate these random numbers for us at some fixed time interval. And that object is going to be metronome or metro. Metro outputs a bang message at regular time intervals. So let's type a space, and you can see that the first argument is going to be that time interval. And the unit of time that we commonly use in Macs is milliseconds. So there are 1,000 milliseconds per second. If we wanted this to generate these ticks or these bangs 4 times per second, then the time interval would be 250 milliseconds. So that's going to be the time interval. Let's now set an attribute. If we open up the attribute window here, you can see all these different attributes that we could specify for this metro. Attributes are just like arguments. These are parameters that change how the object works. The difference between attributes and arguments is we can specify attributes in any order, and we can omit the attributes that we don't care about. So this is useful when you have objects that have lots and lots of parameters and you only need to change 1 or 2 of them. You can do that using attributes, and you can do those in any order. We're just going to type at and then the name of the attribute we want to set. And I want to set the active attribute to 1. So I'm going to type at active and then a space, and then this value is the value for the active attribute. And what that does is it just makes my metronome automatically start. So now we're automatically generating these random numbers. So the inlets on our metronome are the left one that starts and stops it. So we could start and stop it using like a toggle. So T gives us a toggle, and that gives us a 0 or a 1. And let's lock our patch and click on it. 1 starts it, 0 stops it. Now, you might notice that I'm locking my patch in a different way right now. You can always lock your patch with the lock icon. You can also lock and unlock it by by command clicking somewhere in the background of your patch, and that does the same thing. Okay, so we've got a start stop toggle. This inlet is going to set the time interval. So we already set the time interval here to 250 milliseconds. But if we want to change it, we can send some different number to this right interval, and it's going to override this default parameter value that we set with the argument. So let's add another number box here by typing I and then connecting it. Lock the patch, turn this on, and now we can make our metronome go slower using a larger time interval or faster using a small time interval. Okay, And then let's just save our patch. I'll put this in the Google Drive as random beeper. Okay, so let's make a new patch that's going to use some jitter objects. We're going to go to File, New Patcher, and here's our new empty patch. And let's start off by making a display system for this jitter patch using this object, jit.world. This object is going to give us a display for the output, which it's easy to make this go full screen if we want to using the escape key. So that's super handy. Let's add a couple attributes to jit.world. Actually, first let's give it an argument. The first is going to be just the name of the world. So I'm going to name this world hello. When I do that, the window that comes up is hello. This will be useful later on when we make more sophisticated patches and we want to specify the context in which certain operations are happening. We can specify this is happening in a context, the name of which is hello, or whatever the name of your world is. Let's also, you might notice that that display window doesn't stay on top by default. I like to have it stay on top. So you can change that by setting the @floating attribute. This enables the floating window style, and set that to a value of 1. And now that stays on top no matter what we're doing, so that's kind of handy when we're working on the patch. Finally, I'm going to set one more attribute, which is enable. And if I set this to 1, it's going to turn on the jitter processing by default. Okay, now let's just try to display the output of a camera inside this floating window. The object that does that is called jit.grab, digitize video from an external source. So let's take the output of jit.grab and send it to the input of jit.world. And we don't see anything yet. We need to explicitly open or close this camera in order to use it. So I'm going to make a message box by typing the letter M. Oops. And let's send the message open. So you'll notice that Max does this convenient thing where when we make a message box and start typing, it actually shows us this list of messages that the objects in your patch understand. So it's showing me here that we could send it the message close. So open and close are going to start and stop cameras if we're using them with jit.grab. So we're going to connect these two messages to jit.grab, and that will allow us to click on the message boxes to open them, and now we can see the camera is actually sending video signals into jit.world, or we can close them. Bye-bye! And that camera is now closed. Okay, so let's open it again, and we're getting video output. Let's do some processing on this video signal. Let's convert this color signal into a grayscale signal. And the object that does that is jit.rgb to luma, converts RGB to monochrome. So let's just take this patch cord and I'll just boop it out of the jit.world, And then let's look at the output there. Okay, so same thing, but grayscale. And what I want to do, the idea on this patch is I want to take the brightness of this video signal and use it to control a sound in some way. So if I want to measure the overall brightness of this video, I can use an object called jit.3m, and it gives me the minimum, the mean, and the max value of a jitter matrix. So mean is the average value, and that's the second outlet. If I hover my mouse over it, let's print out these values. So I'm going to take this output and send it to this object print, and this is going to get printed in the max console. You can open the max console using this button. So it's showing us that we're getting this kind of average brightness value. Right now that's around 85. But if I do things in front of the camera, like put my hand over it, you can see that that average brightness value goes down to a really low number. And then if I take my hand off of it, it goes way up. So this gives me some way to interact with my computer using the camera as this kind of like wire hands-free device. So let's take this number and use it to filter a sound. So let's make a new oscillator. And the oscillator I'm going to use this time is a rectangular oscillator. So this is going to produce a different kind of sound than the sinusoidal oscillator we used earlier. Let's set the frequency using this first argument. And let's just listen to what that sounds like. So let's connect the output to the left speaker and the right speaker. And we don't hear sound yet. And the reason why is we need to turn audio processing on. So let's turn on audio processing. Okay, so that's what a rectangular oscillator sounds like at this frequency. Let's run it through a filter. The filter I'm going to use is this one, a state variable filter, SVF tilde, and I'm going to specify the center frequency of this filter. We're going to talk about filters in a much more detailed way in a few lectures. For now, let's just take our output and send it to the input of this filter and look at all these different output versions we get. There's a low pass filter, a high pass, a band pass, plus a notch. Let's listen to the low pass. Okay, so the low pass filtered version of this sound is much more muted. All of those high frequency buzzy parts of the sound spectrum have been filtered out. And what I want to do now is control this filter using the brightness of my camera. So when I make my camera really dark, it goes down to like, I don't know, let's say 40 or 10. When it's at its darkest, it's at 10. And when it's really bright, the value goes up to like 120. So let's map this range of numbers into a different range, which is going to make more sense for our audio filter. And I'm going to do that using an object called scale. So scale, you can see it maps values to an output range. So this is going to take 4 or potentially 5 arguments. You're going to have your input low, your input high, output low, and output high, plus, if you want, an exponential factor. So we're going to say the incoming low range was around 10. The incoming high range was around 130. And then let's map it to some outgoing range. So let's say a really low frequency for us is around 20 cycles per second. And let's go up to a much higher range of Let's try 2000. So we'll take this number, run it through our scale. Let's look at the output. And you can see this new range here. And let's take that and control our filter with it. Okay, so there's a audio visual patch right there. We're taking our camera, we're sort of flattening the color information, turning it into luminance values. We're taking the average brightness, we're changing the range of that brightness into something that makes sense in terms of frequency, and we are changing the way an audio filter works based on that brightness. So let's save this patch and we'll call it, oops, camera to filter. Okay, that's it. That's what we got for you. That's our quick introduction to the Max programming environment. As we move along, we're going to talk about, in a much more detailed way, what all of these objects are doing in terms of signal processing, but this should hopefully help you get started with just reading patches and understanding how you can send things to objects and receive things from them and change some of their parameter states using arguments and attributes. Thanks for stopping by. I'll see you next time. Peace.